Hey, what's up, folks? Welcome back to another 3D Hangout. My name is Noah Ruiz. I am a designer here at Adafruit. Joining me every week is my brother, Pedro.
Good morning, everybody. I'm Pedro. It's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. It's a show we combine 3D printing, do electronics. We try to do a live stream while doing all this. Hello, everybody. Welcome to the show. We're hanging out in the Discord chat room. Pedro, give us a shout out to all the folks.
Good morning, everybody.
Discord
Hanging out in all of the chat rooms. We are hanging out in the Discord at discord.gg/Adafruit, at the YouTube channel, as well as Twitch, Facebook, and Periscope. Good morning, everybody. Hanging out. Shri, Andy Calloway, Michael P, Rosin. Good morning.
Yeah, we have a special projects to share today, and we're going to run through the housekeeping, and we'll jump back into the Discord chat room to say hello to everybody joining in. Had a little bit of issues with streaming, but that is how the game goes. Let's go to jobs.adafruit.com and see all the latest job listings. You can head on over to jobs.adafruit.com, see the latest stuff. I'm going to run through them real quick. I'm seeing a new position for basic 3D modeling in the anywhere United States. Awesome. And I'm seeing a Make Inspires Makerspace is looking for a Makerspace manager in the New York area. How do you say this one? Chapaka? That sounds cool. Also seeing an AV content coordinator for New York for the New York Historic Society. All great things. If you're in the market for a new maker position, or if you're an employer looking for some maker help, you can do so by going to the jobs at jobs.adafruit.com. Cool. Let's check out adafruit.com/free and see all the latest freebies going on. These are going to get automatically added to your cart. And there's 3 different tiers. For orders that are $99 or more, you get a free half-size Permaproto breadboard PCB. For orders that are $149 or more, you get a randomly selected Stemma QT breakout board. If you have an account with Adafruit, make sure you don't get the same one twice. And for orders that are $200 or more, you get the Stemma QT breakout, the half-size Permaproto, and free UPS ground shipping for continental US only. So for the deets, check out adafruit.com/free. Give a shout out to the newsletter. This happens once a week. It's focused on products. So if you want to get the latest products that are added to the Adafruit shop, you can go and subscribe to the new newsletter at adafruit.com/new newsletter. Shout out to all the folks that are submitting your stories and links to be featured on the Python and Microcontrollers newsletter. Shout out to all 9,000 of the subscribers are on that. So if you are looking for a place to showcase some awesome projects with Python and microcontrollers, you can submit it to cps@adafruit.com or hit up Amberella on any of the social channels with some hashtags. Thank you, everybody. Huge shout out to Paul Cutler for doing up the Circuit Python show. Season 2 is back in action, and we have Melissa, who's on the Adafruit team this week, so you can listen in on some backstory on Melissa. Cool. All right, and heading back over to the Discord to catch anybody who wants to say hello.
Good morning, Jack Bruton and Connor McHarder. Good morning, everybody. Vince, hanging out in the chat as well. Good morning. Jack says, "Oh yeah, baby, it's that time again." Woo-hoo. Yes.
All right.
It's that time for
some cubes.
Some pixel particles.
Pixel particles. All right. This week's project is a 6-panel RGB matrix cube. This is a 6-sided cube, and it's
so dope.
It's using the Adafruit RGB matrix bonnet to daisy chain all of these together, and it's using the Raspberry Pi 4 as the brains. So let's make this a little bit bigger. These panels we have 2 different sizes of them, 2 different cubes. This is the cube that uses a 2mm pitch panel, and the thing about this one, it's a little bit more tricky to build. because we have fully 3D printed frames that snap fit with the help of some magnets. This was a collab project with Philip Bergas, Paint Your Dragon, and it was quite the challenge on all fronts. So we're super excited to have it ready and out there for folks to maybe build their own. So this is the Pixel Sand demo. You might have seen it in some of the Matrix Portal projects. It was quite the challenge to make this work with 6 panels. It was even more of a challenge to figure out how to power the damn thing. So we're going to go through all of that and more. Super awesome.
Can I brag that this is the first
Ever
LED
in the
cube?
world. Yes.
Hold on, let me snap
You
that.
may have seen some cubes before, but this uses the accelerometer.
No. This is a real LED cube. All the others you've been seeing, they are just one-sided. They don't go across all the panels.
Right. It's really tricky to get the typology correct and to get the particles to go across all 6 panels. So you can see.
That's right. All 6 panels, not one side. All 6.
All 6. Yeah. So we're going to take a look at how to build it and some tips on building it.
Andy says, I sense Lars approaching. Yes, Lars makes his cubed debut.
We have a few demos, so let's run through this. This is the sand demo that you guys might know already. It's using the LIS3DH Accelerometer. We'll take a look at that in a minute with the details, but let's look at some different demos. So I'm using terminal and I'm connected to the Raspberry Pi over SSH, so I can do a couple of different commands. So let's do the globe. Give me a second to type out commands. I got to do sudo /globe. So this is the Earth with the globe kind of script.
So the Earth is flat, huh?
Earth
but
is
in a cube.
In a cube, yeah. So we have a couple of different images that we can play with. We have some details on creating your own JPEG/PNG images for this particular demo. This takes just a JPEG and wraps it around to make it this spinning thing. So it's pretty neat. So let's do a different one. We have Jupiter. We can do Jupiter, I think. Yes, here's Jupiter. So that's one of the stock images we were able to find from NASA. So there's the polar caps there. Be mindful of, the refresh rate is something that you get on webcams, but in real life you don't really see it that much. Here's Jupiter. One of the things that Phil B wanted to do with the globe script is to make it so that you can change out the polar coordinates so that they're on a corner. So we can do that by adding a little setting to the script. So here it is as a polarized. So you can see the polar caps here now in the corner, and that's a kind of cool way to do it. So we have details on how to create your own maps, and I'll do some. We also have a static image viewer. So let me get that going. Image viewer, and then I have to say where the image is. So let's do this creature of habit here. Here's a little creature. It's Lars. Lars has made it into the cube.
Look at Lars.
Hi, Lars. Welcome to the show. It's good to have you here.
Let me see his chin.
His chinny chin. Yeah. All right, hold that up while I execute some more commands. So you can make some really bizarre images. Here we have another one. Get ready for this one. Who's that man?
Who is this?
Who is this? That's right.
Our very
It's
own John Park.
We have converted him into a blockhead.
No, he's in Minecraft now.
He's a Minecraft cube head. Yeah.
Hold
Shout
on.
out to JP for
No, I don't have a shirt that I can
know.
put my...
just wearing his head. Wearing JP's face.
I know, it's so cool.
You too can make your own JP square head. Yeah, very pricey one head, but yeah. Shout out to JP for creating this on short notice. We needed a good free image to test this out, and JP's head ended up working out really well. He did a nice UV texture map of himself here, and
I thought we had a custom
like
Lars icon. I can't find it in the chat room.
Yeah, it might be. I don't know.
Oh, is
might
it
be
in
only
our
for Slack?
Slack?
Yeah.
Ah.
So we can do other things like a Minecraft cube. Let's do the Minecraft cube. This is what we showcased in our YouTube video, just to show some text to show the different orientations. So we have all the back, left, right, front, top, and bottom. And this kind of helps me figure out how to open the thing. So let's go ahead and open it. We recommend using panel number 0, which can also be referred to as panel top, to open it. And to open it, we recommend, at least with this cube, because it's so close to the edges, we recommend using a tool like this here to get the magnets open. They are neodymium magnets, so they're pretty strong. Here's a look at one of the panels. Just go ahead and disconnect it, because it's easy to do so. But yeah, we're fully replacing the stock frame from the 2mm pitch panels. So they're about 120 millimeters. And we have two different styles of tabs here. So we have these flat tabs and then these vertical tabs. That allows us to create the cube. And a really important thing that we learned here is to label all of these edges with these letters. Each frame has a different number indicator to allow you to know which panel is which, and they can only be attached one way, and that is for both cube designs. And that just makes it so that you can only configure it one way, and we want it to be hard-coded so that because doing the math is quite challenging to do the orientation differently. So we want folks to build this in the exact same way we have. So that's why we added these little raised labels. You could use a Sharpie to kind of bring those out. I'm going to try to focus. I don't have the webcam focusing tool open, so I'm going to need a second to open it.
I am posting all the links.
See if I can, yeah, thanks. See if I can get in there. So yeah, we recommend getting a Sharpie and do it. You could also do a filament swap, but we recommend using some good PLA that is sturdy and maybe a light color so that you can make these letters pop. But yeah, these magnets are 1/4 inch in diameter and an 1/8 inch thick. They are press fitted into these little tabs. I've glued them in place because I just want them permanently fixed. But they have a really snug fit, and they have these escape holes so that if you ever get the polarity wrong, you could always try to pop them out before you glue them. And yeah, so that's a look at them. The way to get these frames, they are only going to fit one way on these 2mm pitch RGB panels. So what we're doing is we have the orientations of the data in and the data out. They're marked here on the PCB, and that allows us to know which how to daisy chain them. We also have these orientation arrows here that kind of shows you what the orientation is. And like I was saying, each one of these panels, the frames rather, have a different number. It's 6 different frames, and they start with number 0. So the last frame is number 5. And that just helps us ensure that when you're building the cube, you're going to get the correct orientation. So let's take a look inside the cube. To power the cube, we're using this super nice 5-volt, 3-amp battery pack. It says so right there, 3 amps. We currently don't stock a battery that can do this, so we have a link to pick this up on Amazon. And I'm just trying to get a look at the labeling here. So we have 5 volts, 3 amps, and it has 2 USB ports here. We're using rather short USB cables so that it can fit inside there. Now to daisy chain all of the panels power, they come with these little power connectors. We have we've kind of modified it a bit to remove some of the extra wiring. And then we're using these power distribution buses. So they're like screw block terminals, and they're all sharing power and ground. it's starting to flicker, so you really want to be careful. I have taken this apart probably too many times because I just had to. So as I'm playing with it, it's flickering, so I'm really afraid to to play with it. And there it goes.
Oh no.
Yeah, I have taken this apart so many times. You wouldn't want to do that, you know?
But that's because you're building it.
Literally, yeah. So, just so you know, the first 3 times I've taken it apart is great, but the more you do it with these screw block terminals, unfortunately, you're eating into them. So that's what's going on. I just need to re-tin those wires and get them in there. But we have 2 of these distribution buses. That's what we have in stock. Maybe there's a smaller version, but it's able to fit inside there.
You need to screw them like tighter in there?
No. If you take out these wires, they are chewed up. You see what I'm saying? They're chewed up because I have taken them apart many times, more than I'd like to admit. So I'd have to go and re-tin all the wires. You don't have to do that if you're first building it. Just throwing it out there. It's looking okay so far, right? Okay. Another thing is to be very, very careful with these panels. These panels have gone through many prototypes, and along the way, a couple of pixels just kind of come off. Here's a few of them, just to show. Like, that's just one of the things that will happen if you are brute forcingly installing these panels. So be careful with them. Yeah, so everything's able to fit inside here. This is a smaller panel. One of the cool things you can do is just, you know, they can all be separated. So here you can see like this label D, you just want to line it up with D, and I, you line it up with I, so there's no way to incorrectly do it because the labels, they all line up perfectly. You just got to be careful. With the data cables, we have a great chart that shows exactly how to daisy chain them together. So that's really cool. What else can I talk about? I'm just like dancing on, walking on eggshells here with this. Game of Life is a really cool demo as well. Let me see if I can fit everything back together. Paige is going to take a moment to...
Real quick, looking at the comments and questions inside of the chat room. Mike P is asking, do the magnets affect the circuitry or the panels?
No, they're far apart from the panels, so it doesn't seem like it's interfering with it in any bad way. The issues we were seeing with the flickering is, again, my wires are just chewed up.
And then general comments from Jack and DeWester saying the math alone must be crazy.
Yeah, we need to...
Probably one of the best programmings I've ever seen in a long time. Yes, this definitely wrecked Philby's head. With all the crazy math that's spanning across all 6 panels. And then Andy Calloway suggesting Borg Cube. Yes.
Yeah,
we got something that looks like it. The Game of Life demo. Kind of looks like it. Whoa.
Oh, let me do it with color. I think it's K/K3. Yeah.
Whoa.
Yeah, so this one shows cases of color, but this is a special version of Conway's Game of Life, and it's been written to work with these 6 panels, so all the typology is going across all the different corners and sides. Let's get another look at it. On this one, hold it up, Pedro, like this while I execute the command. Kind of looks like a firework exploding. Ready? 3, 2, 1. Whoa. This is a really cool one. So yeah, all the cells are trickling across and exploding, and there's all sorts of different colors going on.
Trying to show where you can see it span in between the different ones.
Let me run it again because it tends to kind of die out as life does. There you go. Run the life sim again.
That's so cool.
Yeah, very, very sweet. Conway's Game of Life running on a 3D cube.
How cool is that?
All these demos are written by Phil B, by the way.
That's a good one.
Yeah.
And then Andy Calloway's saying he's become a big fan of the Wagyu connectors.
What are Wagyu connectors? Is that what those power cables are? That'd be cool. We also have the Death Star.
Ah, these right here that snap in. I think we carry these.
Oh, those are cool. Yeah. If we could find one with 7, then we'd be in business. This is the Death Star in the Globe code. The Globe demo, rather. You can see it's kind of... maybe it doesn't translate so well. Not everything's going to translate well with the Globe demo, but it's cool to kind of see it rotating and across, all the edges and stuff. So this is a cool one.
One we did not get a chance to get into. Jack was saying about the Matrix Rain code. Yeah, Lamar did request.
So
them,
what's
but we
cool
ran out
about
of
the
time.
software portion of it is that it can keep getting more demos, more features as time progresses. So that is one that I think Philby might still do. But you're more than welcome to do a fork. The code is up on the GitHub, and you can submit a PR if you want to do some improvements or some other demos.
Yep, I did post
Really, really cool.
the GitHub link for the code. And then the panels are in stock.
Yes, they are. So now that I've talked about the 2mm pitch, this is the finest pitch panels that Adafruit stocks. So let's go ahead and look at the 2.5mm pitch panels.
So you made another one?
Yes, I did.
An even bigger one?
An even bigger one. So these panels have curb cut frames. Curb cut frames. That means they have a 45-degree bezel, and they're chonky bezels. They have really nice M3 heatset inserts. So I was able to create these brackets that feature the magnets, and they're way easier to install. You don't have to swap out the bezel because the bezel is designed for like a cube, the way that it just is. So what we have here is we went ahead and we printed out some labels. This is panel 0, could also be referred to as panel top, and their letters here match up exactly how the other cube matches. They have the exact same labeling system, and they're in the exact same orientation as well. But these are the same magnets, 1/4 inch diameter, 1/8 inch thick. And yeah, it's really nice to do this one. It is, bigger. I think it's like 160 millimeters, maybe 200 millimeters, but the frames, they stay here. So that's awesome. You can print these little brackets. You're going to need 8 of these, and this allows you to pop off the bottom and the top panel. And panels 1 through 4 are secured together with these corner brackets. So you have 2 sets of brackets. You have the top and the bottom brackets that allow you to snap these on and off, and then you have this assembly here of 4 frames that kind of create the box without a top and a bottom, and they're firmly secured, so these cannot be separated because they're fastened together with these M3 screws. There's one of the heatset inserts you can see. So that's the deal there, and then there are magnets that are press fitted into these corner brackets, and that allows the top to just fit in there like that. You can kind of just get a look at that corner there. There is a little bit of gap here, there's a good amount of gap here. That's by design, because if we try to smash them closer together, you're going to run into some issues where you won't be able to, the screws won't be able to fit in there. So we had to kind of, balance that. And, well, the Pi honestly gets hot, so it's good for ventilation. And if you want to power this like all white with white colors, the battery won't have enough juice. So you can always have the RGB matrix bonnet have a power cable through one of these edges.
Yeah.
So that's another thing. But it's using the same power distribution rail. These aren't quite as chewed up because I did not have to take this one apart too much, but it is a lot more room in here. We were able to fit 2 batteries, one for the Pi and one for the bonnet. So let's kind of connect that up. So I need to plug this into the data in. All of these ribbon cables come with the panels. So do the power cables. Power cables are also kind of rejiggered a little bit so that there's not so much wiring. But they're all using the same power distribution bus. Go ahead and plug in the Pi.
Real quick, McGuffin and Jack are both saying the snake game
Oh, that would be so cool.
on the cube with the LIS3DH.
Yes, I think a snake game
Awesome.
would be cool. Also, a labyrinth type of marble type game would be really sweet. So the Pi's booting up. There is some code that you can do to do an auto start. I haven't done that yet because I'm still
Configure some stuff.
I still got to configure. But I'll go ahead and shut down our small cube so it doesn't melt away. And then I'll get the bigger cube fired up on SSH here.
And then other things is a voice meter with an ASCII voice meter.
Ooh.
More suggestions on
some cool demos,
some cool
right?
demos, yeah.
Okay, I'm just getting my new terminal.
Magic 8 cube.
Oh yeah, like shake it and get an answer, huh? And then I need to turn this on. All right, and then we should be able to cube it up. All right, I just need to plug in this battery to the RGB matrix bonnet.
Oh. Duester says this might be a good application for pogo pins.
Oh. So if you can see, I just stuffed in the batteries. There's plenty of room for Doritos and other snacks. I gotta line up the J, H, L. So you can see here, there's the L. So I just need to rotate it. And now you'll be able to hopefully see this snap right here and there. Okay, cool. So let's get this camera going. So here is the bigger cube. There is some wiggle room in there for the batteries, but that's totally fine. Just want to be cautious of that. It's so much heavier, you guys, with two batteries. This is like 10 pounds. But it is a lot easier to build, in my opinion, because you don't have to replace the stock frames. The stock frames really make it easier to build. But these are a little bit more expensive. I believe these are $10 more each panel. And they're a little bit more power hungry, I could say. I've noticed trying to run some of the demos on here kind of freak it out. So that's why we recommend getting a 5-volt, 4-amp power supply, because our battery can only do 3 amps. The RGB matrix bonnet says you need at least a 4-amp. So it's just a miracle that this works at all, honestly. I think it's because, there's a lot of black here, and that means they're not all lighting up. So that's why it's able to kind of get away with it, to be honest. So let me run another demo and see if I can, I think the globe is okay.
Here's one we didn't think of, a holocron.
Oh, that would
Dang
be
it.
great. Yeah. A Portal Cube is another one from the game Portal. A companion cube, rather. I'm going to try to do the globe. Pseudo globe. So here's the globe. It runs pretty well, even with the power constraint not being perfect. That's still pretty good. But I think it's when I tried running Lars and I tried running JP's head. Yeah, I kind of had a heart attack. So let me see if I can do that. Python image viewer maps/JP. Yeah. So unfortunately, JP's head is
top
a
of the
little
head.
glitchy. Yeah. Because it needs a lot of power. Maybe there's a command that can reduce the brightness. But just to be aware, folks, that's what you're going to get with the bigger cube. It really is better to power it off a 4-amp 5-volt power supply. Because again, the bonnet needs at least 4 volts to power them at full brightness.
Right.
So we have a glitchy John head here on the bigger cube.
Looks pretty cool still.
Yeah, for sure. And at least the demo, the globe, and whichever other one works Let's see what let me cd into the maps directory and see what image they have. Earth, Adafruit, Boing, JP's head, Jupiter, Minecraft, Moon, and Rubik's. Do you want to see Rubik's Cube?
Yeah. Oh, I haven't seen this one.
Let's do the Rubik's Cube.
And then Connor's saying that may be a cool way to do a party game.
Right.
Before people get a question or requests with the answer on top. Huh. Just like the You Don't Know Jack game.
Yeah, okay. Oh, I need to
That's a good one
go
too.
up one folder.
Simon Says.
These things, those would be cool.
Hem is saying that maybe there's a wireless charger so you could just plop it right on top.
That would be brilliant. Yeah.
Oh, wow, yeah.
This one's a little glitchy too because it's trying to do white. It's like, I can't. I need 4 amps. Why would you give me 3 amps?
560 is saying some of the newer USB batteries pack can pump out 5 amps of power. You just need to use the PD trigger to DC cable adapter that can spoof an e-maker.
Yeah, y'all be able to definitely get this running then with no power constraints. Cool. Those are all great tips. Those are in the Discord or YouTube?
This is in Discord.
Okay.
This
Cool.
was from 560. Is that the stuff that Lamar was showing off? The PD trigger? That USB cable?
I might have missed
the
it.
5 amps?
I may have missed that one.
You sank my battleship with a speaker in there as well.
Let's do. It's all these commands are in the learn guide. We'll walk through it a little bit, but just wanna...
Jeff Bars loves the blockheads. That's a good way to get like all the family portrait. Get everybody's head on there.
There was a Maker Faire project that was really. Oh, okay. Well, I can't run the Minecraft one. That's fine. We'll have to do with sand demo.
Yes, that's exactly what I'm talking about. The PD trigger cables, says 560. Yep, that was the one that Lamar was talking about.
Okay.
We'll definitely pick those up.
Yeah, for sure. Yeah, I definitely need to try that on this. So there's still some things to test out with the bigger cube. It just needs more power, y'all. So thank you for some tips. Yeah. Bigger panels, more power hungry. So what would y'all build? Which version would you guys build?
Everyone's amazed.
The small one that's a little bit more tricky, or the bigger one that needs more power? There's a trade-off, and that's sort of the balance you have to do. You know, one's easier to build, requires less 3D printing, but yeah, there's some power things to figure out there. But I like the space here. You know, there's a lot of space inside.
Yeah,
the
I like
bottom
the
can
bigger
also
space.
come out too, and it doesn't seem like there's too much weight that like pulls it down. Yeah, you know, there's what 1, 2. There's 8. There's 8 total magnets that are holding the top and the bottom together. So they're good enough to keep it all sturdy. I wouldn't want to throw it to you, but you could. I wouldn't.
It's pretty
recommend it.
heavy. Yeah.
Yeah. And again, to get the
And these are like kind of sharp too, so you.
yeah, the edges can be. What I'm doing is just running the globe so that I can get an idea of where I am. Like, where's the top? Where's the bottom? Well, that's the bottom, and that's the top, because it's just the way we oriented it. So this one you can kind of get your fingernails under it because there's already a gap, but you want to be careful either way. So, and this is the kind of way to take it up, to turn it off, right? It's such a thing. If I leave the USB cables plugged in, it'll probably die. But you know, SSH is your friend. You want to run a sudo halt command or whichever command to turn it off, and then you know, they'll still stay on. You know, they tend to stay on the RGB bonnet. So I'm just gonna disconnect this and disconnect that. We're still looking pretty good. These batteries have a 10,000 milliamp capacity, which is right there. And again, these are 3 amps. So Very cool. All right, let's take a quick look at the Learn Guide. It just went live a couple moments ago.
Yes,
so
I did post. I did post the guide link everywhere on tweets and the all the chat rooms.
Cool.
So that and the video, it is set to unlisted, so you can watch that as well.
Yeah.
And then quick before we change subjects, Hem is saying trying to get some of those TPU bumpers on the edges for a big LED dice.
Oh, that's a good idea. Yeah, that could work.
It would like mess with you, like you roll whatever 6 and it changes the snake eyes or whatever.
Yeah, that's a ballsy one. All right, so we have some good things to be aware of. This is a quite advanced project. We recommend folks
This would
take
be good.
considerations. It's quite pricey to get 6 RGB matrix panels. These are 64 by 64 RGB panels, and they can be pricey once you add everything up. So you want to take that in consideration. You also want to consider that the 3D parts are designed specifically for these versions of panels. So if you want to get panels elsewhere, just be aware they might have a different mounting system than the panels that we're talking about here. There are some tips here on like how to take care of your cube. You want to be very careful with it. As you've seen, as I was developing the prototypes for the frames, it was very difficult to not break the pixels, so that's just the thing. But yeah, we have 2 versions. The RGB matrix bonnet is for the Raspberry Pi. It just makes connecting a Hub 75 connector easier, and it has some extra pins and stuff that are broken out nicely. It needs a DC barrel jack power to power that separately from the Pi. So that's why we have 2 batteries for the big one and 1 battery for the smaller one. The Raspberry Pi 4 is recommended. It's fine to use the 2 GB of RAM version. They're kind of hard to get right now, so just throwing that out there. This is our accelerometer. This is the LIS3DH. It's our favorite one. It's easy to connect to now that it has the STEMMA QT connectors. So you can just plug and play these sensors now, which is great. Some extra bits, the power distribution, a couple cables, and some screws. You can use the black nylon screws for these 2 versions. Parts that you'll need to get elsewhere is the magnets. So the magnets, we say you need at least 48. I recommend getting more, maybe get 60 or 100 of these magnets just so you have more in case something goes wrong or for the next project. These tend to work really well. We've used them in like maybe 3 or 4 different projects now, these neodymium magnets. The 5-volt 3 amp USB batteries available on Amazon. You'll need 2 of those depending on the cube you want. And then we have this special USB-A to DC jack cable that works well for the bonnet. And there's some other M bits here. You'll need some other tools. Okay. The 3D printing page has a couple of animations showcasing the CAD assembly. So for the smaller cube, you can kind of see how all the frames are connecting with magnets. The Pi and the LIS3DH are secured with some M25 screws to this separate bracket. That bracket also gets magnets and just gets attached to the bottom panel there. So that's the smaller cube. And the bigger cube has the top and the bottom panels that have magnets, while the panels 1 through 4 are attached with these side mounts and screws. Very similar method to secure the Pi. Here in this animation, we don't include the Pi, but the Pi gets mounted to that green bracket along with the LIS3DH using similar hardware.
Real quick, Hem is asking, could you replace everything with, say, 32 by 32 panels?
Yeah, you could totally. Depending. So that panel, the 32 by 32 panels, will have different mounting holes. Absolutely. Every time I've done something with a 32 by 32, the panels are always different.
Even from supplier changing to.
That's what I'm saying.
They'll move around.
Literally the same SKU number, and it's a different thing. Like we've already went through this with our first sand demo game with the handles. Like, thankfully, folks like Melissa remixed it, and other folks have remixed it. All I'm saying is, yes, you can definitely use our CAD as a reference point on how to get it right, how to get the orders right, if you want to run this code. However, I don't know how
Scaling would work.
how the code would scale to a 32 by 2 by 32. I guess you could run some other code, some of the default code, but yeah, it would be different. But yeah, I think we have some good reference now for folks to build different versions of this kind of cube. We have STL files available to download for free. Also the source file. So we have a step file of each cube. And we also have the Fusion 360 file of each cube. So they're all nice and editable. So things for their slice settings when you're if you want to make the smaller cube, you're going to need at least 150 millimeters on your 3D printer's bed, and we recommend some good PLA that you've tested and is proven to be like good. It's not gonna like break away. I personally wouldn't recommend some of the silky type of filaments.
It's very weak.
Those tend to be very brittle and weak. Great for looking statues.
For statues, yeah.
Not so good for mechanical parts like this. Another thing to note is like the line extrusion width for your slicer. We tend to use 0.4 millimeters, and that tends to resolve the labels. If you can get a look at this, like look how clean those labels look. Right. So the number, it's important that your labels look good, and we have these screenshots to share how your G-code render should look like. So just follow the reference, the line width and the wall line count. Sometimes you put more or less, but for tolerances, we're saying do 2.
This is going to get easier with the new engine. The I forgot the name of it that Cura 5 is using, because they're able to do variable widths, so that'll be a lot more easier to get a nice, clean, small details without having to do all the crazy work that we're doing here. But that'll be in the future. It's still in beta.
Okay. Print one at a time and test out the magnets. They should be really snug fit. I wanted them to be snug fit on purpose, and later in the guide I'll show you some tips on how to install them.
Real quick, Paul Cutler is asking if the Pi 3 will require different holes for mounting the Pi. I don't believe so.
I think the
only
3
difference,
and 4 have the same mounting holes.
Yeah, the mounting holes are the same. The only thing that's different, which does not it doesn't matter here, is the ports.
Yeah.
It's the mini HDMI. It gets in the way of what the 3 had.
Yeah.
The 3 doesn't have that. So for this, the mounting holes should work perfectly with
all
the
the
Pi
ports
3.
don't really matter that much
because they're all inside.
Yeah, they're all inside. The Pi 3 has a micro B power or USB-C power. They're about in the same location. So you'll just use a different style
No,
of
it is
cable.
a B.
Okay.
It is a B.
Yeah, you'll just use a different cable. I believe you could use a Pi 0. I'm not sure. Don't quote me on that. Maybe. Just to do static images, I'm sure you could.
Maybe.
So if you want to just do static images, yeah. All right. And then slicing the... oh boy, I need to update this. Slicing bigger cube brackets is what I should say. Yeah. So these brackets can be printed without any support material. They print vertically. And because of the geometry of the circles, the overhangs kind of catch themselves. So similar kind of slice settings. Here are the frames for the smaller cubes. You'll note that each panel has different labels on them. And here are the Pi mounts. They're slightly different, just to accommodate for like the bigger cubes. So we have 2 different Pi mounts, and they're separated in folders in the STL download in the zip file, so they're separated. And this just gives you a little bit of detail of which panels the side and corner brackets are going to get mounted to for the bigger cube. So from here, this is where you want to start like figuring out okay, do I want to build the smaller one or the bigger one? So our pages here are just named as accordingly. So frames for the smaller panel. We run through prepping these out. Here's a little tip. I like using these vice grips to press fit, or rather force fit, the magnets into the cubes, into the tabs. So that'll be fun. And then you can use glue if you want. I did. So yeah, removing the frames, we're actually using the screws, the existing screws that we take out of the frame. You get a lot of them, so save them in a little bag. We're going to use them later here. So here you can see we're using the screws, just 4 of them instead of like 8 or whatever they use in the stock frames. And then we have this really nice reference sheet for the frame labels. I recommend maybe printing this out on paper or having this on a device so that you can always pull it out when you're assembling the panels together. But yeah, that's with this image, this reference sheet, it shows you exactly the data arrows. Let me see if I can make an original. Yeah. So here, let's say number 5, panel number 5. You're going to want to reference the arrow for the data in, arrow for data out, and then your orientation arrow. And then you'll want to add these labels to the edges of your frames, your bigger frames, because these are kind of already added in the smaller frames, just because we had to replace the frame, right? So we went ahead and said, we might as well add labels to those frames. But still, it gives you an idea of the orientation of installing the 3D printed frame. So here's a look at that. And really, they're only going to go one way because the frame actually has some capacitor. Take a look. So if you take a look at this edge here, we're right there within like 0.5 millimeters of clearance. So we had to be very careful with these two tabs here, vertical tabs. So they're only going to fit one way, and that's a good thing. Very well. Okay. All right, so once we have those frames ready, we can start building our cube. Here we're going to set up our pie mount with some magnets. We want to test fit it before we install the pie mount so that we get the polarity of the magnets correct. That's a big thing here too. Getting the orientation, the LIS3DH accelerometer is very critical, so please reference this photo. The best way to see is just looking at the labels and looking at the placement of the mount. So hopefully this image is nice and clear, so folks will get the orientation installed correctly the first time. So that's a big thing there. And here's another look at it, at the accelerometer. It's got to be installed correctly, folks. So this is like the back view of it. And we're using M25 hardware and hex nuts to secure the LIS3DH to the little Pi mount. Cool. And then the Raspberry Pi uses M25 sized hardware as well. So we have 4 standoffs, and those standoffs get secured to the Pi mount. And again, just reference the labeling and where the ports are to determine the correct orientation of the accelerometer. Before installing the Pi into the cube, you kind of want to set up all the cables onto the Pi. As I found taking it apart so many times, it's really difficult to start plugging in USB cables once your cube is already assembled. Once your Pi is in the cube, how do you get to the cables? They need to be installed first, is what I found. So you end up with this like octopus looking board with all these wires hanging out. Notably, it's just the RGB matrix bonnet has a USB cable, and the Pi has a USB cable. Also, the RGB bonnet needs 2 extra wires that are going to screw into the power distribution bus. So that's why there are all these appendages coming out of the Pi. All right. So then from here we look at the bigger cube assembly. A lot easier. You're just marking on the edges or doing labels. Here's the exact same reference sheet. What we really like about this is both cubes are ordered and kind of put together in the exact same orientations. So that's really good. So here, setting up the brackets, and here are some animations to showcase like how to determine the polarity of the magnets. That's really important. So that's why you're seeing an outside view and an inside view of how the side brackets are attaching to the brackets, the top and bottom brackets, side mounts and brackets. I need better terminology, whatever. So from here though, the built-in curb cut frames have these heat set inserts that are M3 sized, and they just screw into them really nicely. So I'm using these nylon screws. So we want to get panel 0 and panel number 5 with these brackets, and then panels 1, 2, 3, and 4 get the side mounts. So that's what we're building here. So to start building the frame, like the 1 through 4 panels, I recommend installing 4 side brackets to panel number 1, and then kind of bringing panel 2 to panel 1 with the edges labels matching, and then you secure that together. Then you do the other side, so connecting panel 4 to panel 1 with screws. So then you have 3 panels, it's almost closing it off, and then finally panel 4 attaches to panel 3 with some screws. And at this point, it's important to note you're going to want a very thin screwdriver. Take a look at this photo and you can see it's close quarters, y'all. It's very, very close quarters. So having an extender bit like this works out, right? So this won't fit in the cube, so thankfully I can just do that. And then I'm just using this this screwdriver bit extender to get in those close quarters. You
So
could
have
use
that,
a jewelry style.
We have
right?
that 45-degree angle bit too.
Oh, that's
so you
a-
can like.
Well, you
angle
need
it
to
at 45.
turn it. You need to turn it. So how would that work with 45? Oh, because
There's an arm. There's like.
I
a
wouldn't recommend a drill here.
No, you don't have to use the drill. You can use your. It's just like that. It's a bit.
Okay.
It's a bit.
Okay, well, whatever tool you all got, it's close quarters, so you want a thin screwdriver. It's just that last panel that's hard to make, but you're essentially making this kind of box frame, and whenever you're doing that, it's hard to attach the screws. So that's what your box frame looks like. And of course, you want to make sure all the edges are matching, all the labels match. And then from there, we can start getting panels 5 and panel 0 ready. Yeah, and this is where you want to start installing the cables, because you'll need the cables installed before installing the Pi. So here you can see how the Pi fits on top of panel number 5, and like the power cable for panel number 5 is kind of being right angled to go underneath the Pi mount. But yeah, at this point, you have your data cables, and you can start plugging the data in from panel 5 to the Hub 75 port on the RGB matrix panel. Yes. Okay. And then from here, we want to set up the Pi mount for the bigger cube. So this just kind of runs through that, being very aware of the placement of the accelerometer. It's got to be installed correctly. So you want to reference these images. Cool. Wiring up and preparing the RGB matrix bonnet. So in order for the bonnet to work with 64 by 64 matrices, you kind of have to do a little bit of jumper work. So on the back of the PCB, there is some jumper pads. So just want to bridge pad E and pad 8. It's all documented here. And then we're using a jumper wire to connect GPIO number 4 to GPIO number 18. So you want to do all that. All this is documented in the RGB Matrix Learn Guide, but we wanted to break that out so that you're not missing that step.
It's a pretty important step.
Absolutely, otherwise it won't work. So installing the LIS3DH, we kind of have to solder to the bonnet, but you can easily connect a STEMMA cable to the ports on the breakout. So that's nice. So we're just setting up that wire or that cable, and then you're going to want to solder to VCC, 0 clock, 0 data, and ground. And that's kind of what it looks like there. But it's nice that you can disconnect the thing easily or plug it in easily after you soldered it, of course.
Nice.
Yeah, but all these steps, no matter you're building the big cube or the small cube,
Still gotta do this.
it's still going to happen like this way. Cool. Next up is setting up the power cables. The stock power cables come like this. They come like in a pair of 2, and it has a lot of wires. Each connector has 4 wires. So what we're doing here is we're basically removing them and leaving 2. there's because they're kind of jumper cables, you can use a tweezer to kind of poke at the pin and release it from the plastic clip. So that's what I did here, and that'll just make it so you don't have to use all the wires when you're using the power distribution bus. You just kind of run out of ports, so that's why we're trimming these down and reducing the wire count. So if you have 6 panels, you're going to have 6 of these cables, so you're going to want to prep each one individually and have them tinned and ready to secure to those power distribution buses. These 2 extra wires here are for connecting the distribution buses to the bonnet. The bonnet has voltage and ground screw block terminals, and that's how it's getting power, external power to it, to those displays. So whether you're doing the bigger cube or the small cube, you're going to need to set up these cables in the exact same manner. All right, from here we can start setting up our Raspberry Pi. You want to get, a fresh installation of Pi or update it. We have lots of stuff here on setting up the library. So this is using the LED Matrix library from Henner Zeller. And we have some credit to him. And it's a GNU, General Public License. And then you're going to want to install the script for the Adafruit RGB Matrix Bonnet. So we walk you through that. And we walk you through kind of just installing those scripts. The next page walks you through getting up your first panel. So this right here shows you a nice diagram of how everything's connected. And then there's some more verbiage. And then here's some scripts on how to get to the right folder and then how to execute the demo code that is a part of the library. So you want to get these running first. And then there's just a lot of little things to poke at if you are running into some things. But here is another really nice, what would you call it? A graphic that shows you how they're all daisy chained together. Cool. And these were from Philby. Very cool. So you'll want to note that the first thing that connects is 5, and it kind of goes backwards from there. So panel 5, 4, 3, 2, 1, and then 0. So if panel 5 is the bottom, well then panel 0 is the top. That's just a random thing. Here's some more demo code to test out your panels to make sure that they're all working. This one I think shows you how many rows are connected. And yeah, you should see Hello World scrolling from left to right on all the matrices, which is crazy. That's a cool demo too. This long matrix panel. All right, and then we start breaking this out into mother pieces. Here's some things you need to install. This is the actual demo code for the matrix cube. It's hosted on GitHub, so you can check that out. Here's the demos breaking out for you. So the image viewer is the static way to see the topology of the cube. So that's the image viewer code. Here's how to execute it. And then here's some other things here to note if like it wasn't coherent. Here's the rotating globe. You can run it this way. There are some options that you can use for the globe demo. So pulling out the specific JPEG image, this is how you would do that. And then, yeah, or the Python version or the C version. We have C and Python versions for both of them. The C version runs way quicker. So if you want to do a really stellar demo with like the best frame rate, you want to do the C version. There's more broken out documentation for all the, I didn't even see, you can do it in seconds.
Oh,
you
wow.
can set the sample per pixel. So there's a lot of customization you can do, which is great.
Timing.
I'm gonna need to walk through all of this myself. And then Conway's Game of Life. This is how you would run that demo. You have 3 different flavors of Conway's Game of Life.
Gosh.
Yeah, I know, right? One that does colors, one that does a heat map, and then another one that does grayscale.
All right, speed round. It's lunchtime.
Holy moly, y'all! It's freaking 12. Oh man, another week where I don't get to do a prototype.
That's fine.
I mean, it's because it's 2 cubes.
Which is, I need to mention that.
I'm out of.
I forget who it was. Was it Jack?
I need a drink of water.
Was it?
I'm thirsty.
I forget where they were. They were asking about next week's project. I think it was 560. They want to know where the lightning bolt lamp is. It's
That's
like, oh, that's
560.
that's next week's project.
That's next week's project. I don't have time to
in the
talk
chat.
about it. Sorry.
People want that now. Next week.
More code documentation. We run into the small cube assembly. This one's chronological. Just follow it through, and you get all the panels attached. Yeah. But yeah, just careful chewing up those wires when you're using the distribution buses. I mean, yeah, definitely thoroughly documented every step, because it is a hassle to build this cube and get all the cables plugged in the right order. It's a crazy build. I want to actually try this out after the show. It's called auto start on boot. So there's some couple commands. There's a service you can create to get it running on boot. I don't have this yet, but I want to do that. And then we have a dedicated page on making images and some code for the various demos. So JP, shout out to JP. So if you want to do a crazy head, here's a good reference image to reference. And here's another one of the Minecraft block. And then just some more charts. Again, I recommend printing this out. And here's another image of the globe. What's in the box? Pain. Yes, I'm pained out, man.
Where does the corner stand? Is it in the other room?
Oh, yeah, it's on the photo booth area. Yeah, we have a stand as well that uses M3 standoffs and screws, so you can stand it up and prop it at a corner angle. This is good for the global caps.
Yeah, I think Hem or somebody in the chat room was asking.
Yeah, we have a stand
for a corner stand.
Yeah, you could tweak it to make it fit better. I think the fitting here is okay. Just be careful with it. It's just a plate that prints like flat on your bed, and then I'm using standoffs to kind of elevate it, because you kind of need that.
I would use those rubber. What is it? The little rubber sphere. Yeah, those big ones.
So the idea is that this fits in one of the corners. So just orient it. Be very careful not to break away any things. So that's how it looks like. I can't really get a good shot of it.
Here. No, I just got it like that.
Yeah.
So it just stands in there like
that. It just stands in like that.
It's in.
So
bam.
Obviously, maybe print it with some translucent material. I think I had pink already loaded, so I was like, okay, pink. But yeah, this is included in the STLs, in the STL folders for both cubes. They use the same thing. They use the exact same stand. I guess I could do it this way.
Oh, there you go.
Yeah. Yeah.
Looks like
but maybe we'll make some different, more stylized stands, because right now this one's pretty basic. I didn't even include it in the list, the file list. But yeah, that's one way to attach it, right? To make it stand up. That's how we kind of made this just for the photos, so that we can rotate it, on a corner, because it's kind of the best way to showcase it, right? All right. Well, this has been overtime. Lots of things to talk about with the cube.
Lots of stuff. Some
of
the things that are out of stock, though, is the Bonnet and the Raspberry Pis. Yes. I would keep those web pages open, periodically refresh them throughout the day. I think the Pis go out, and is it in the morning when they've been setting stock? If there's any left.
There's a Pi project in the works that will notify you when they're in stock with a loud siren. So can't wait for that one.
Maybe next week, I think.
That's a Liz and JP collab. Don't tell anybody. It's gonna be awesome. Are you sure we can't? Do we want to save the dragon for tomorrow, or
let's save it for next week? I'm
really
hungry. Yeah.
Oh,
just quick comments from the chat room. People like JP's Quake/Doom 3 skin / Minecraft.
Yeah, that's funny.
Macro reviews. Yes, everything is on GitHub. STL files, the code, page walkthrough.
Yeah, the STLs are hosted in the Learn Guide. I haven't published it to the other repo sites yet, because time, but those will get out there shortly too. But right now, you can grab all the STLs from the Learn Guide. They're hosted there as a zip file.
Learn on GitHub as well. Check that out. All of the Learn code and guide goes inside there.
Yep.
So you can put some issues and comments or do some pull requests.
Yeah, we'd love to see some demos from other folks.
Post that in there. Some
Tonight
other
we have,
questions?
we're winding down the show. So thanks everybody. I mean, really appreciate y'all hanging out and listening to us.
There was a bunch of banter I can't go over
I
on
know.
the
I'm
Discord.
sorry.
Very good read. Check it out. People looking for some crimping tools, some other wires, replacement 5-volt cables for RGB LED matrices.
Oh.
So if you need more replacement cables, we had chat on that. The power rails,
yes.
DINs.
Yeah, different.
Checking the Discord.
I forgot
for-
the name already of those snap fit wire buses. What are they called?
They are called. I posted the link in here. It is the power distribution 7x6
Right.
solid brass.
I saw somebody say there's other ones that like snap that don't require screwing. So yeah, try those out.
There is, unfortunately, no for Interweb Fiend asking if there is a kit that this could be bought for kids doing some STEM projects. This would be such a great STEM project, but no, there are no kits, unfortunately, with the supply and part shortage.
Yeah, we don't think we can. Yeah,
Yeah,
kits
we
are
can't.
difficult to do these days.
Yeah, because then we have to allocate parts.
Yeah.
And we can't sell those parts because they have to be all grouped together.
Yeah. I mean, AdaBox is like a kit too. and
That's
it's
why
like,
we had to switch to
wow.
seasonals.
Mhm. Yeah.
So yeah, just
Maybe
like I was saying
someday.
before, have the pages for the products, or sign up, get on the email alert list for that.
Okay. Well, thank you everybody for joining us. We have more shows later tonight. We hope to see you on a very special edition of Show and Tell.
Yes.
It's going to be hosted by JP with co-host Liz Clark, Let's See
cool.
DIY.
We'll be there.
So they will be hosting tonight. I can't wait to share more cube stuff and have JP's head looking at JP. It might break the internet. And then shortly after Show and Tell, it's at 7:30 p.m. Eastern Time, by the way. At 8 p.m. Eastern Time is when Ask an Engineer happens, a full hour of Lamar and Phil with open source hardware news, new products, Python on hardware news, and more. Yep. Tomorrow's John Park's workshop. And then Friday is Deep Dive with Tim. Fridays at 2 p.m. PT or 5 p.m. Eastern. Sweet. We do the show every Wednesday. You've been watching 3D Hangouts with me and Pedro. We do the show every Thursday.
I think
every Wednesday.
we used to do it on Thursday.
Yeah.
One thing that I see Yanni and multiple people posting in the chat rooms. Yes, happy May the 4th. We are
didn't
all
even
dressed
say
up.
It, yeah.
I know. Forgot to bring out our lightsabers and
check
dark
out the
sabers.
Dark Saber project. This is the way. Whatever.
Yeah.
It's a great love
Where's
project.
Grogu? Where's Baby Yoda?
He's down. He's in my room now.
Oh.
That's where I bought him. Yeah.
So yes,
May the 4th be with you.
I was gonna be a jerk and say,
Live long and prosper.
Yeah.
I beat you to it. We both can coexist in the universe. Well, thank you, everybody.
Good luck on all your maker endeavors.
Hope to see you later tonight.
And with that,
But until then, remember to
great.
make a great day. Make a Star Wars day.
No.
Make it-
No.
Don't do that. Bye,
See you later
everybody.
tonight.
We'll see you tonight. Adios.
Bye-bye.
Here is Lars. Rawr.